So hello everyone, welcome back to my YouTube channel Hasta Education. So in today's video I am going to discuss about determinant method to solve a system of equations involving three variables. So let's start. So here it is the determinant method to solve a system of equations involving three variables. Okay. So let's say you are given a system of three equations like a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z is equal to d3. Okay, so what is your first task? The first of all, write the given system of equation in standard form. So this is the standard form. So you have to write the given system of equation in this standard form. So here it is the a system of equation is given like 2x plus 3y minus 7z is equal to 5, 4x minus 9z plus 3y is equal to 8, 6y minus 61z plus 3x is equal to 11. So please note that this system of equation is not in the standard form because it is not in the order. Here it is x, y, z, it is x, z and y. Here it is y, z and x. So this is not in the standard form. So our first task is to convert or to write this system of equation in standard form. So here it is the standard form. So all the x are at same place. Similarly, all the y's are at same position and z are at same position. So this is known as the standard form. Okay, this is our first test. That means we have to write the given system of equation in standard form. Okay, sometimes it is given haphazardly, so you have to write them in systematically. So first x terms, then y terms, then z terms. Okay, so after writing the system of equation in standard form, our next task is to find out or to define the following determinants. Okay, so these are delta, which is given by the a1 b1 c1 a2 b2 c2 a3 b3 c3. This is the determinant. Okay, and this is known as the coefficient determinant. Okay, similarly we have to, this is the coefficient of x, y and z respectively. Okay, so then we have to define the delta 1 determinant, which is given by d1 d2 d3 b1 b2 b3 c1 c2 c3 determinant, and this is the matrix obtained by replacing first column by d1 d2 and d3. Okay, similarly we have to define d2, that means we have to replace the second column by d1 d2 and d3. Similarly we have to define another determinant, which is the delta 3, which is the determinant of a1 b1 d1 a2 b2 d2 a3 b3 and d3. That means we have replace the third column by d1 d2 and d3. Here the d1 d2 and d3 are the constant terms. Okay, so after define the three for determinants delta, delta 1, delta 2 and delta 3, our next task is to check the value of delta. So there is two possibilities. The value of delta can be 0 or it can be non-zero. If the value of delta is not 0, then the system of equation is consistent and it has a unique solution, and the solution is given by x equal to delta 1 by delta, y is given by delta 2 upon delta, and z is given by delta 3 upon delta. Okay, so when delta is equal to 0, then you have to next check the value of delta 1, delta 2 and delta 3. Okay, so here is again two possibilities. If at least one of the values of delta 1, delta 2, delta 3 is not 0, in that case the system of equation is inconsistent. Okay, if at least one of the value of delta 1, delta 2, delta 3 is non-zero, then the given system of equation will be inconsistent. Okay, if all are 0, that means delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. If all the determinants are 0, then in that case we have to put z is equal to k, and we have to solve any two of the equations, and we have to find the value of x and y in terms of k. So out of these three equations we have to put z is equal to k, and then we have to solve any of the two equations, and we have to find out the value of x and y in terms of k. Okay, put z is equal to k and solve any of the two equations and find the value of x and y in terms of k, solving these two equations. Okay, then if this value of x and y does not satisfy the third equation, then the system of equation will be inconsistent. If these values of x and y also satisfy the third equation, then in that case system of equation will be consistent and it possesses infinite solution. Okay, so this is the steps. So what the steps says, first of all you have to write the given system of equation in standard form, and then after writing the system of equation in standard form, we have to define for determinants. These are the delta, which is nothing but the coefficient determinant, then delta 1, delta 2 and delta 3. Okay, after defining these four determinants we have to check the value of delta. Okay, so if it is not 0, then system of equation will be consistent and it has unique solution, and the solution is given by x is equal to delta 1 upon delta, y is given by delta 2 upon delta, and z is given by delta 3 upon delta. But if the delta is equal to 0, then we have to further check the value of delta 1, delta 2, delta 3. Then two cases arise. If at least one of the delta 1, delta 2, delta 3 is non-zero, in that case the system of equation will be inconsistent. That means it possesses no solution. If all the delta 1, delta 2, delta 3 are 0, then in that case what we have to do? We have to put z is equal to k, and we have to solve any of the two equations out of these three equations, and after solving these two equations we have to find out the value of x and y in terms of k, and if these values of x and y also satisfy the third equation, then the system of equation will be consistent and it contains or it possesses infinite solution. If this value of x and y does not satisfy the third equation, in that case we can say that the system of equation is inconsistent. Here is some important point to be noted down. So this is the first trivial solution. So what do we mean by trivial solution? If all the variables, that is x, y and z, assumes the value 0, then in that case we say that such a solution is known as a trivial solution. Okay, otherwise it is known as non-trivial solution. If the value of all the variables is 0, that means x is equal to y is equal to z is equal to 0, then that kind of solution is known as trivial solution. Otherwise the solution is known as a non-trivial solution. Okay, point number B, system of homogeneous equation. If d1, d2, d3 equal to 0, then system of linear equation is known as linear homogeneous equation. Okay, and such kind of system always possess at least one solution, that is the 0, 0, 0. Okay, the system of homogeneous equation always possess at least one solution, that is 0, 0, 0. Okay, And here is the condition for homogeneous equation to possess non-zero or non-trivial solution is delta must be 0. Okay, this is the condition for homogeneous equation to possess non-zero or non-trivial solution is delta should be 0. If delta is equal to 0, then in this case the system possesses infinite solutions. Okay, so thank you for watching this video.